Hi, we are very much to the end of this CIS 635 Knowledge Discovery and Data Mining course for fall 2024. So in this lecture, I will be mainly reviewing what we have covered as a content of this course, okay? So this was the syllabus that we wanted to cover, and I think we have already covered most of the items. I will slowly go over and try to reconnect what was covered so far, okay? So we are at week 15. That's the second last week of this course, and we only have the exam week left. That will be in the week of December 9, okay? So I have summarized what we have covered, but slowly I will go through all the content item by item, okay? So if you recall, we started with two very important concepts, what you call vector space and distance metric, okay? This is all about linear algebra, and we learned how to put data points or see our data points in a vector space. And one of the items that we learned is how to actually estimate the distance between data points, okay? So we learned about L1 distance, L2 distance, then cosine distance. And we also have spent some time to refresh our linear algebra, calculus, and probability theory background. Then, as far as data science is concerned, we spent some time to learn what is the EDA process looks like, okay? To refresh our memory, EDA is one of the important steps of any data science project that opens the door to pre-process the data in a way so meaningful information can easily be extracted, okay? While doing EDA, we learned about the concept of notebooks. I have seen most of you are actually doing really good coding using Python packages like NumPy, Pandas, Matplotlib, and Plotly to pre-process or curate your data and also for visualization, okay? So to recall, EDA is one of the heavy part of any data science project. And I think we started our project something around the week of 5 or 6, and we are still continuing with that. So all the concepts can be synthesized through a working project from your domain of expertise, okay? One of the steps after EDA is doing some predictive modeling. So mainly we focused on the regression and classification aspects of predictive modeling. And in most of your projects have two parts. One is your EDA, and then depending on what kind of problem you are trying to do through your project, either doing a regression or a classification model, okay? So we learned about the regression and classification tasks, and one of the models that we first learned is the K nearest neighborhood model, because if you recall, this model, what we call a non-parametric model, and you can actually prepare your data through some feature engineering to put your data in the vector space and use some distance metric to do both regression and classification tasks using this simple K nearest neighborhood model. And then we also learned about trees, more specifically decision trees, okay? Again, this is another non-parametric model. And then we learned about linear regressor and logistic regressors for regression and classification tasks, but this is a parametric linear model. I hope that you guys have some idea about why we call these as parametric models. And of course, these are linear models, okay? And then we also learn about support vector machines, both for regression and classification tasks, followed by some ensemble learning. Two popular examples of ensemble learning are random forest model and then boosting algorithm. We learned about some standard data processing techniques before we do modeling. We learn about normalization, we learn about feature scaling and model generalization. And another step to improve your model is hyperparameter optimization. So some of the models, for example, the linear regressor or logistic regressor, and then SVM and even trees, because they have their own hyperparameters. So for example, for random forest, number of trees, the depth of each tree, these are actually called hyperparameters. Unless we do a rigorous hyperparameter optimization, we don't realize full strength of a machine learning model. Okay, so hyperparameter optimization, data processing normalization, model generalization, these are standard machine learning techniques that we need to master on. Okay. We also learned about some unsupervised learning techniques. And one of the popular examples is clustering. Okay, we learned about k-means clustering, we learned about k-modes clustering, hierarchical clustering, DB scan. Okay, so we learned several techniques to do clustering. And to note why we call it as an unsupervised technique, because for clustering we are actually relying on only on the features, because our data doesn't have any level. Okay, but for regression and classification we call supervised learning, because here we are learning the relationship between x, the features, and y, the levels. For regression, the y is a numerical or real value target. For classification, our y is a categorical or binary target. Okay. We also learned about association learning. Two popular examples that we have covered. One we call market basket analysis, and the other one is collaborative filtering. Okay. We also spent some time about time series modeling. Okay, because a lot of data, they have sequential relationship. Okay, for example, the weather data, the temperature data, the amount of items the superstores are selling. These are time series data, and some other data, for example, your genomics data or maybe your language data, these are not time series data but are what you call sequential data. You have a relationship between data points. Okay. For time series data, we have different kind of models. For example, RMA model or some deep learning LSTM models. Okay, you need to learn the general format of a time series model, because these are different than IID data models. Okay. And at the end, we spent some time to learn about neural networks. We only covered one specific neural network as our introduction, what you call feed-forward neural network. I hope you guys have learned something, and at any point, if you have any questions, feel free to reach out to me. Okay? Thank you so much.